DVB webinars. I hope you're all registered for those. But today, as you've heard, we're going to talk about DVB's targeted advertising specifications, and this is an introduction, so you can consider it something of an overview. But of course, if you want to go into any more depth, we have definitely the right people here to try and answer your questions. So that leaves me just to say a warm welcome and to introduce you to our running order today. So we're going to begin with Angelo, who you've heard is the chair of the commercial module for targeted advertising. And he is going to give you a brief introduction to the commercial background. So as Owen has said, this is primarily a technical overview, but it helps to set the scene. We'll move on to Martin, who will give us a presentation on the overview of part 1 on the signaling specification. I will then come back and give you an overview of the ad server integration part 2, and Angelo will come back at the end to giving some information on work that the DVB are doing in the space that's yet to be seen or yet to be published. So that should be good, hopefully exciting. And then, as Owen has said, we'll move to the Q&A. The presentation should take around 45 minutes, so we should have plenty of time for Q&A at the end. Please do use the Q&A questions. Unless a particular question seems pertinent, we'll wait till the end, but we'll try and keep an eye on your questions. And as you've heard, Peter Neumann will be joining us as an expert. Let's call Peter an industry expert on TA, because he certainly, as Owen said, has been here from the very beginning in this process. So it's great to have him around too. So with that, I shall mute my mic and ask Angelo to unmute himself, and we move on to the commercial background.
Thank you. Thank you, Matt. Welcome to everyone to this webinar on TA, and just a brief commercial background on TA with a few slides to introduce the topic. So today, targeted advertising needs no commercial justification. It is a solid reality, a recognized relevant business model by the industry. Even for the linear horizontal broadcasting ecosystem, targeted advertising is a necessary evolution to be on a pair with online video distribution on all these mobile devices and PCs, where addressability of advertising has been a solid reality for many years. And in 2017, a study mission report on TA set up by the DVB project concluded that TA was a highly likely and necessary evolution of the TV and broadcast ecosystem, and that a satisfactory and workable technology framework was needed to enable TA in the context of horizontal broadcast TV, at least for the horizontal broadcast business model. And in January 2018, DVB formed a dedicated working group in charge of identifying and defining relevant TA business use cases on which to build the future DVB-TA specification. This group, called the Commercial Module Subgroup on TA, DVB-CMTA if you like, in short, was chartered to work in liaison with the HbbTV Association to eventually release a set of joint technical standard specification for TA. In the next slide, we see the most relevant points addressed in the future work to define the DVB-TA technology framework in the context of broadcast TV. An end-to-end in-band signaling, so that existing playout signaling can be correctly propagated through a standardized translation mechanism to all TV receivers in order to correctly trigger ad substitution, what we called DAS, or dynamic ad substitution. A seamless switching or substitution in the receiver as perceived by the end user, so that the user experience would be consistent with the quality associated with broadcast TV, providing a better result than current web execution of ad insertion and substitution. A limited but reliable receiver buffer capability, for instance, at 30 second of storage, seems to be necessary to achieve this seamless switching, together with a dedicated fast media switch API, enabling the transition to be more accurate, shorter, and cleaner than it would be if it was done purely in JavaScript. Another important point was to leave ample control and management capabilities over the TA operations to the broadcasters, so that they can manage the end user experience, balancing reach versus quality to benefit from the value generated by TA. On this point, Matt will say something more later during his own presentation. Reporting, a reliable and accurate reporting, so that advertising management platforms and trading stakeholders can rely on trustworthy measurement, avoiding the doubts and distrust that in many instances, especially on the web use cases, taint digital advertising chains. Finally, the DVB-TA solution should be cognizant of privacy regulation and data protection, and facilitate compliance with the new and frequently demanding privacy regulation, the famous GDPR. And finally, it was even emphasized that the DVB-TA specification would probably not be enough on its own, and that certain specific commercial agreements between the ecosystem stakeholders may be required to fully enable the DVB-TA framework. In this last slide, we are going to see, we will see how the TA work was organized. And the DVB would work on standardizing broadcast signaling used by receivers to identify placement opportunities within a service in DVB transport stream. And Martin Gold is going to explain that in depth. The DVB, moreover, work on providing guidance relating to the interface with prevailing digital advertising decisioning systems, and advice on the preparation of media for an optimized viewer experience. And Matt Poole is going to explain that in depth. Last but not least, HbbTV would work on developing the HbbTV terminal specification. And this is the introduction on the commercial topic for TA. Matt, it's up to you. Thank you.
Okay, so
thanks, Angelo. Yes, sorry, I was muted, but yes, we pass on now to Martin, who you already hear is ready and willing to get started.
Thanks, Matt. Thanks, Angelo. So yes, I'm going to cover one part of two parts that DVB has for targeted advertising specifications. This part, which is now part one, covers signaling. It's published as the Blue Book Part 2, but we decided to swap the order around for the ETSI specifications. So if we move to the next slide, this describes the development of the specification. So after the commercial requirements, the first set of commercial requirements were approved in mid-2018. The work kicked off later in the year in TMGBS. Initially, we were also working on feasibility feasibility considerations of SOME-based signaling, but the work here in the specification is in-band signaling. We have come up with a specification that was approved earlier this year in the round of DVB meetings, so finishing with the steering board in February 2020. And this specification is now submitted to ETSI and is starting to progress through that. It has a specification number, so it will be TS 103752-1. So on the next slide, we consider the reference architecture that the signaling needs to be based on. So, this reference architecture considers that there may be more than one party involved in broadcasting content, in both the content provider or broadcaster and some kind of platform or network operator, maybe different parties. So we need to consider formal interfaces between the two. And if we go to the next slide, we'll see, looking at the AV signal progressing through this architecture, the broadcaster might be performing the initial encoding, and so that's the first point at which we would have need to have targeted advertising signaling. Then at an interface between the broadcaster and the platform operator, this could still be in the form of the uncompressed signal, or it could already be compressed and then possibly further remultiplexed, or just transcoded as well as remultiplexed as it goes through the platform. And then the final version of the signaling as a transport stream reaching the receiver also needs to have the signaling. So we consider these three places for the signaling format, and this is illustrated in the next slide. So, starting with the uncompressed signal, we have adopted the SCTE specifications, as this was really a natural place to start. And so this one is, when it's uncompressed, it is the SCT 104 format of messages that describe how to create an SCT35 message. And very helpfully, the encoders that support SCT35 generation are quite widely available, and they also combine the generation of SCT35 messages with stream conditioning, meaning that at the point where a stream switch or splice needs to be done, a random access point is generated to facilitate the splice being seamless. So this slide illustrates how the encoded signal as a transport stream might go directly to receivers, or depending on the network operation, might involve further remultiplexing, possibly with transcoding operation. And then if we go to the next slide, this emphasizes the SCT35 being received directly by the end devices, so going through to the distribution end. So worth mentioning now the SCT35 message format. It's based on the MPEG sections, and it signals both the timing of a placement opportunity and an identifier or some identifiers for the placement opportunity. So the receiving device both knows where and some information to guide what it should be via the ad decision process that Matt will describe further. So based on this SCT35, DVB profiles this specification, considering both its usage in the contribution stage between the broadcaster and the network operator, and its use in distribution to the final receiver. And that's typically in the vertical market, where receive devices can be built that do process SCT35 messages. And then in the next slide, we consider the horizontal market. So that's the bottom part of the slide, where we have DVB-defined signaling converter. The purpose here is that we start with SCT35 messages, but we translate them into DSMCC stream events. And the reason for doing this is that the main target population for horizontal devices corresponds to the HbbTV ones, and these do have support for DSMCC stream events, but they do not directly support reception of SCT35 within the HbbTV specifications. So on the next slide, please. This describes a bit more about the SCT35. So we're both profiling and extending SCT35 in the DVB specification. So we have two types of placement opportunity that are available as SCT35, and we decided that we should support both of them because the one that is in most widespread usage, the splice insert message, is according to the SCT35 specification now considered a legacy format, and that systems are being encouraged to move towards the segmentation descriptor in a time signal message, which can convey the same sort of placement opportunity information. Since we're at that transition point, it didn't seem like we were ready to just say go with the future message format, because there was not sufficient support yet in the industry. And to facilitate that potential transition from splice insert message to time signal messages, we also define an optional additional descriptor which can be used in splice insert messages that allow the additional information that's possible in the segmentation descriptor to be conveyed in a splice insert message. So it kind of levels them up so that they're more equivalent. We do note in the specification that SCT35 is also useful and used for signaling other types of content boundaries. We don't say a lot about that in the specification. We're really noting that this is possible, and the DVB specification is not seeking to limit that. We do specify to enhance interoperability a specific format of the unique program identifier that's found in the segmentation descriptor. And so we specify a URI format that guarantees interoperability by using the namespace of the domain name of the broadcaster as a way of ensuring unique spaces, followed by an identifier. And for the identifier, we recommend the use of the airing ID format. So that's 16 hex characters, but that's not mandatory. Broadcasters might have other identifiers that they prefer to use, and because we have the interoperability guaranteed by using the domain names, we don't really need to standardize the identifier itself, the identifier part of that UPID field. Then the final point to note is that we recognize in transcoding operations that PTS values may need to change, will typically need to change for transcoding, and SCT35 message format helpfully has a PTS adjustment field in a fixed place close to the start of the message. So the DVB spec allows the use of that field, so the receive devices that are processing the SCT35 messages must take account of that PTS adjustment field when using the PTS values in the messages. And on to the next slide, this then shows how for the HbbTV devices, they can still receive an SCT35 message by encapsulating it in the DSMCC stream event. So this is a new DVB specified format. So so what you see there is the payload of a stream event, which is so that's carried by a stream event descriptor in the DSMCC format. And so if we run through the fields, so we have usually an SCT35 message at the end of this event payload. We start with some DVB defined data that describes what follows essentially. And so starts with the length field of that DVB data section. Then we have a couple of flags, the timeline type and the event type. So the timeline type allows, as well as using PTS values in the SCT35 message, we can alternatively use time values on a TEMI timeline. And to make that equivalent, we need a TEMI timeline that is a 90 kilohertz one, so that the values would be similar in behavior to the PTS values. And so we identify with this flag whether the PTS fields in the SCT35 message relate to the usual system time clock in MPEG, or whether they relate to a TEMI timeline. And in the case of a TEMI timeline, additionally in this DVB data section, there is some metadata to identify where to find the TEMI timeline. So, that can be extracted via the data in the PMT. Then the event, so worth mentioning in this diagram, anything in italics is optional, may not always be in the message. So based on length fields or flag values, whether the data is present. The other type of flag, the event type, controls whether the event is actually carrying a full SCT35 message, or just a URI reference to a message carried in a DSMCC carousel object. So we introduced the latter type, the carousel object URI, to deal with large messages that might be in excess of the maximum payload of the DSMCC stream event. So this caters for messages more than 180 bytes long. And then, so a couple of other, we'll just continue on that slide, please. So a couple of other points, the DVB data field is designed to be extensible. So we have some reserved data area, which we can start drawing upon by varying the value of the length field. We also follow the DVB data with optional private data field controlled by that length field. And if there is private data, then it's preceded by a private data specifier. That's the PDS there. So I think I've described that, other than the very last point being that that entire payload is base 64 encoded, as that facilitates receiver APIs that may not cope with, that would not cope with binary data. So now on to the next slide. This now describes a bit more about the differences between contribution and distribution signaling and how we convert from one to the other. So in the case of SCT35 messages in the distribution signaling, there is little to do because it's the same format used in both contribution and distribution. However, it is quite possible that the contribution format, the contribution signal may contain additional messages intended for other kinds of devices, not the end devices, and these could be filtered out on the way to distribution. And this is where we recommend use of multiple PIDs for different SCT35 messages intended for different consumers of those messages. One of those consumers could be the signal converter that's encapsulating in DSMCC stream events, for example. And then we note that where there's remultiplexing with transcoding, that the PTS adjustment field helps with that part of the conversion from contribution to distribution. And then just consider the stream event distribution signaling further. I mentioned we have both TEMI timeline and PTS possibilities for the timing information, and the preference for one or the other really depends on the details of the deployment with the different transcoding and remultiplexing functionality, and whether that equipment is tailored already to support SCT35 remultiplexing, or whether it would better handle TEMI timeline, which has its own requirements regarding how it should be handled in a remultiplex. So it's worth noting that HbbTV supports both types of time reference. So this is really a network deployment issue, not a receiver design issue. Okay, so that concludes my overview of the specification, which hopefully gives a flavour of the different parts of the specification. So over now to Matt to describe part 2 of the specification.
Thanks, Martin. That was really, really great. So as we've said, let's move on now to part 2. By way of an introduction, part 2 was originally developed within a task force of TM-IPI working group, and was published as part 1 originally as a DVB Blue Book back in November 2019. It's now maintained with its own working group along with the signaling spec you've just heard about in a working group called TM-TA. And it was as we did the preparatory work for being standardized through ETSI that we switched. This new working group decided that it would make better sense to switch the part numbers, as it made more editorial sense, we thought, to have the signaling before the ad server, because that's logically there. And also importantly, this part of the specification is informative. It's a guide, whereas the signaling specification is normative, so it's inventing new specifications. So we felt it was better that way around. In this presentation, I'm going to spend a little bit of time looking at the main interfaces of the part 2. I'm not going to spend an awful lot of time describing ad servers and standards around it. I'm assuming that there's some knowledge of that already, but what I will try and focus on is situations which will, in the context of broadcast ad substitution, which might be different to ordinary digital ad substitution as we would already understand it. And as Angelo mentioned in his commercial introduction, I'll touch upon the reach versus quality trade-off point, and finally some, which Martin already touched on a little bit, general guidance for broadcast streams and receivers that also are in the specification. So here is the reference architecture you have already seen in Martin's diagram, and it obviously constitutes the full ecosystem for DVB-TA as we saw it, whereas Martin's world, what is there within the playout and coding multiplexer and producing the TS stream, this part of the specification, what we called interface Vive, Roman V, is constituted in these 3 sub-interfaces between the receiver and the broadcaster. It's not that clear from this diagram that actually what it means is the broadcaster as opposed to the broadcaster's playout and multiplexer, specifically the ad server, in fact, actually, which is there. This is what we cover. So the three parts of the interfaces, if you've seen, we're going to cover are the ad request, the response back from the ad server, and a couple of points on the measurement and reporting of the adverts. So this is in the specification in part 2. We have this more zoomed in reference architecture of a DVB-TA system. You can see the three interfaces, the ad response. So the ad request originating in the DAS app, it's the dynamic ad substitution application, and coming back as a response, and some media being requested, and as play out is happening, advert impressions, which is essentially the measurement going on. So I'm going to deal with each one in turn. So essentially an ad request is just a HTTP request made to the ad decisioning server. And in our part 2 of the specification, it's made by an actor named the ad requester. Now, we abstracted it out to an ad requester because we wanted to draw attention to the point that it could be either the DAS app itself or a proxy, a server-side proxy for the DAS app. So this is not normally this way in digital advertising on the web, for example. But they're both essentially acting as a handler for the vast response from the ad server. But as I said, DAS app's proxy is perhaps a new concept. And the reason we wanted to introduce this is it's number one is a way of managing scale. Because this is all tied to linear, all the ad requests are going to be happening within the seconds leading up to the insertion of the advert, the substitution of the advert. So, and at full broadcast scale, as we hope we will reach in the coming years, it's going to be very large. So some business logic outside of the ad server, which may not traditionally deal with that sort of load, could be handled. It's also a possible way of addressing privacy concerns. So you may want to avoid sending personal information to an ad server, but you do want to find a way of still, whilst being anonymous, identifying that it is a unique request. So this may be a place where that can happen. The specification doesn't go into this because it does talk about making sure that you operate within regulation and law, such as GDPR. It doesn't talk about going to techniques for addressing privacy concerns, but as an architectural approach, this may give you an option. So this is another reason why we put it in place. And also it may be used as an abstraction layer for service providers or platform operators, where either one of them have multiple broadcasters as customers, and each one of those customers may have multiple different ad servers. So if you're wanting your DAS app proxy to remain common to multiple broadcast and ad servers, then you may want to extract some of the routing logic out to the proxy as well. So that's kind of a new concept within the ad request, but otherwise it's still a VAST request. VAST, if you don't know what that means, is a video ad serving template, which we'll deal now in. The second part of the interface is the ad response. So it's, as I've said, the ad response is a VAST formatted HTTP response body, which contains, most importantly, two XML entities: the media file entity, which contains all the locations to the advert median, so whatever types of files they might be, MP4 files, fragmented MP4 files, dash streams, etc., somewhere on the internet on a CDN, and also impression URLs. An impression is an individual view, if you like, and each one of those has a URL which is described in the VAST response. But the important thing here we wanted to talk about is in ordinary digital advertising, you're not having to do too much to match your advert media with anything particular. It's all operating within the same context. But of course, within broadcast ad substitution, you're operating within a transmitted broadcast stream and a IP delivered advert. So in order to sustain and achieve the best possible switching and the best possible user experience, there's some need to try and match. And I've listed some of the things here you might want to try and match for various reasons. For best results, we recommend that the codec and resolution is matched with broadcast. This just gives the decoders optimum chance to sort of make the transition. If you don't have to reinitialize the decoder, then you get time saving. And we're talking milliseconds are important here, so every optimization is good. In the horizontal market, which most importantly refers to HbbTV receivers in this context, that might not be possible. For example, where you've got an SD broadcast service, which might have an MPEG-2 video, MPEG-1 layer 2 audio, a match might not be possible because typically the digital adverts are served as AVC1, MP4 wrapped media files, and HbbTV as a browser tech doesn't support streaming over IP and MPEG-2 video. So if you're in that configuration of thing, then you may need to do a little bit more work to get a good transition. We'll come to that sort of the trade-offs in a little bit later, as I said. There may well be a greater expectation to deliver, although this is probably changing now, but greater expectation to deliver access service files in a broadcast context. Whether or not it's regulated is still market dependent, of course, as these things are, but it's just a consideration where you may not necessarily be receiving full subtitles and audio description, and the viewer expectation, even though it isn't regulatory necessarily, they may expect there to be these things there. So it's another consideration I thought was pertinent to pull out. And technically speaking, whilst in the IP world, it's often you will have a alternate audio track as a broadcast mix containing the original audio and the audio description as a separate track. To achieve maximum reach with access services, it may be necessary to provide an entire video encoded with the AD mix in, because some receivers may be busy and not be able to switch to alternate audio tracks. So it's just another consideration when you're dealing with a full ecosystem of receivers. And the final point I wanted to make is that this is where you'll list, if you're using adaptive media, your dash manifest will be listed in the ad response. And it's recommended that you try and at least match an acceptable level of quality with the lowest bitrate representation in your stream in comparison with the broadcast service. But if it's an SD stream, then yeah, it's an SD resolution, but you need to think about the bitrate as well in that, which perhaps it's fairly obvious for anyone coming from an IP world, but it's the expectations for what might be adapted to may differ in the context of delivering IP that's inserted or substituted on top of broadcast. And the third interface being measurement and reporting. Now, there isn't a lot different, actually, technically speaking, about this. So the DAS app or the DAS app proxy would parse out the impression URLs from the ad response, and at the appropriate time, it would send an impression cap to the URL, and it's usually a quartile tracking, which means 4 times per advert at 25, 50, 75, and 100%. So that really doesn't significantly differ. but I did want to, as Angela rightly pointed out earlier on, you really do need to put a lot more consideration. But actually, it's probably true to say now that in everything that we do, that's anything to do with targeting, you really do need to consider privacy and data protection. And again, it's just the fact that it's within the context of broadcast, which has always been unidirectional rather than bidirectional, that you really should make sure that you consider these things. So whilst the point one is not again in scope of what we specified, you might need to consider if how you're targeting things might require consent. So you might want to think about how you collect consent as part of delivering your DAS app, depending on the level of targeting or device profiling being used. So which means that you need to be sensitive to the viewer, because some viewers may not understand that it's even being targeted for markets where this is new. And just a general point that the part 2 recommends that everything's over HTTP, which secure HTTP requests. There isn't really any reason why you wouldn't do this. And there is a question on which it's a good time to deal with it actually on from Vincent Gessian. Why didn't you specify VMAP instead of VAST? So we went by what broadcasters say that they were typically using, rather than using VMAP, which is essentially a playlist of individual adverts listed all together. We went with ad pods in a VAST response. That's mostly because this is what members said that they were doing in the industry anyway, but also because we're targeting individual spots rather than the playlist. You could also, another subtle point, we didn't specify anything. So this is just guidance and recommendation. So it's entirely possible for someone to also author a DAS app to specify an entire advert break as a VMAP. But since the specification is trying to deal with individual spots, and the receiver population, particularly with the horizontal market, can only deal with preloading an individual advert, you're going to get the best response if you deal with the best sort of user experience and therefore best commercial experience, as it were, if you did them an advert at a time. So those are some of the reasons why we ended up with VAST with ad pods as opposed to VMAP, which is essentially like an advert playlist. I hope that answered the question. But I'm sure you'll let us know if you need a fully formed answer than that. Yes, so this leads us on to the second part of this section, talking about this important commercial requirement of facilitating reach versus quality trade-off. So what do we mean by that? So reach, I'm sure you're all aware, just means how far you can go. In the context of targeted advertising, this means how many potential users' eyeballs might see an advertiser's campaign. And so obviously the greater the reach, the better it is for the advertiser and the broadcaster. Quality refers to the picture quality, yes, but most importantly, the accuracy of the switch timing and the duration of the switch. So now that's simply recognizing that there are multiple different receivers out there, all of different price points, all of different hardware capabilities, differing numbers of decoders, different stream technologies available, and you can get maximum reach, but you can't expect to get excellent substitution on all receivers. So some broadcasters may decide that they only want perfect transitions, and so they're going to get the greatest opportunity of that if they limit the reach. Others may prefer to go for greater reach, and on receivers that are less capable, they may have to do a little bit more work to make it seamless to the viewer. And we talk about a little bit more about that in the next slide. But with that, the whole fundamental principle of DVB-TA was designed to allow broadcasters to make that decision as to what they would want to have happen on their channels, which, you know, and I've spoken about why. Of course, this may differ between vertical and horizontal market deployments. Somebody earlier on asked a question on the Q&A, what's the difference? I answered it's essentially pay TV versus not pay TV, but vertical means where you own the entire stack. So you may own the back end, IP back end, and the hardware, and some of the broadcast head end. Whereas in a horizontal market, the broadcaster has a head end and maybe some of the back end, but it's a TV receiver delivered to DVB specifications, and you know, there's no ownership of the device within the broadcaster. So in the horizontal market, the reach versus quality trade-off is probably more important, where you have control over the full end-to-end than you know, for a pay TV operator wanting to have advertising, or a platform operator with customers. Then you may, where the device and the software belongs to you or your partners, then you can probably get better response. But this is an important fundamental thing for the specifications. And importantly, as I've already mentioned, close matching of the broadcast codec with the advert isn't always possible. So that's another consideration of when this might happen. You might need to consider this. And as I've said, different receivers have different hardware, so you may not have enough memory to do a good transition. One of the fundamentals we haven't really called out here is that the DVB specification requires that at least one advert can be fully preloaded into memory. Either a receiver doesn't have it, then if it's possible to determine it, which is not always possible to determine, then you can make a decision whether or not you're going to do it anyway, or you may have to just abandon the transition if you do not manage to fully preload it. And that's all in the decision being made by the broadcaster as to whether or not to try things or not. And to facilitate the decision at the last possible moment, the guidance speaks in the part 2 speaks about 2 approaches at the point of the ad decision. So just in time, there may be other ways further upstream, but in this interface, a broadcaster has a couple of different ways of how he might manage this trade-off. So these are characterized as the DAS app approach and the ad server approach. The DAS app approach expects the ad server to return all possible media types available. And depending upon what it knows of the current context, it will make a decision based upon logic it has to determine whether or not an ad transition should go ahead based upon rules that the broadcaster has built into it. This may reduce the number of parameters built into the VAS request, but it's not as good for inventory management, because it might lead to many adverts decisions that are served that can't be fulfilled with a successful substitution. So in managing and in ad trafficking in an ad server, ideally you need to have some confidence that an advert will be fulfilled, and this would lead to a lower confidence of that. And the alternative is that the DAS app can collect as much information about the current context of the receiver, the broadcast channel, and anything that's happening at that point in time to determine between whether or not to give the ad server that opportunity And this approach, obviously, that does then allow the broadcaster only to return a decision to make an ad server make an ad substitution if they think it's the right thing to do. So therefore, there's still inventory left later on for another opportunity to serve that, and it just reduces that level of complexity. But it's important to note that there's a large number of ad servers in the market, and many broadcasters use different ad servers, and not all ad servers have the same ability to deal with the configurability that might be delivered. So the likelihood is that there's going to be some combination of both approaches actually when you get down to the nitty-gritty with what's out there in the market and what an ad server can do. Which moves us on to the final part, but I will deal with Masaru's question of what is the relationship between the DVB-TA spec and the HbbTV spec. Do you assume that a DAS app is made as an HbbTV app? No. So a DAS app is a generalized term in the specification that really refers to any receiver logic that controls the ad substitution. So an app, it's slightly misleading because an app in the context of HbbTV is an actual app, whereas in the context of a pay TV set-top box or a platform operator, it's actually just native logic to the set-top box. But it's intended as a generic term. It's not expected that you must do HbbTV implementation, but it includes HbbTV as an option. I hope that answered the question. Oh, beg your pardon. We've already. Oh no, that's it. We were. I was correct. So, and the final part of my slides here are some general guidance, and I've picked out 3 key points from that section. The first of all to consider is when conditioning your stream with signals, that timing is key. Between the announcement that an event is about to happen and that an ad substitution needs to be implemented, you need to be able to allow for a ad request to happen, the response to be generated, a single advert to be downloaded fully, and the switch to the advert to happen. So you need to consider that that has to happen when you're conditioning your signals. You need to allow for time before that to happen if you want to have the best possible switching. You will need to condition the stream in other ways as well, especially for single decoder architectures. Martin's already spoke about random access points. Luckily, most encoders in the market dealing with SCSI already, upon receiving instruction to create a SCSI 35, insert a random access point. So the point between where what we call a placement opportunity is defined should be conditioned to be able to splice in and out, even though it's actually not actually splicing into the actual stream. It does allow the decoder, particularly where it's using the same codec, to have a chance to find its place again. We also just mentioned that because audio and video frames can have different lengths, that it may be necessary to have brief audio silence at the start and the end, probably nothing more than 240 milliseconds, just to avoid any pops or cracks that you might otherwise receive. And this, in quotes, sacrificial material. Sacrificial material just refers to really only first ad in break or last advert in break, or one of the situations where you might want to replace the whole break with a single stream. And in that context, you're less guaranteed to get a good transition, and therefore you might want to editorially condition the broadcast stream to allow a little room either side, takeoff and landing zones. We spoke of it. That shouldn't be always necessary. It's more to do with when you're unable to tackle an individual spot, but it's something we spoke about. On dual decoders, it's expected that you'll get immediate or close to immediate transitions because the broadcast stream is being decoded still and the events are being listened to. So there should be only the time it takes to switch between the graphical displays and render them. So it should be very quick, but just a note to say that not all dual decoders are created equal. You may have a UHD decoder and a non-UHD decoder, although it's important to note that we do not specify UHD yet. We speak primarily about HD in the general ecosystem, although I'm bleeding into receiver spec here, whereas we were not talking about receiver specs in the DVB side. Or you may have a video only second codec that does picture in picture, so it's not that helpful. So it's just in general to say that while dual decoders are going to give you a really good result, you won't get a necessary good, if you know anything about the market penetration of dual decoders, you need to consider that dual decoders in devices or receivers doesn't necessarily mean that the full population of dual decoders are available for immediate ad substitutions. And that is the end of this specification. We've got several questions, but I think I will allow Angelo now to come on and give us coming soon, and we'll, if everyone is very happy to stay along after 3 p.m. for 5 or 10 minutes, we'll deal with the rest of the questions. So Angelo, over to you again.
Thank you. Thank you very much, Matt. So just a couple of slides to show you what is going on in DVB. One work as an additional possible technical solution for TA is based on watermarking, or SOME as we call it, signaling on media essence, where signaling messages of the opportunity are embedded into the essence of the video or audio signal. The aim of this new work is to deal with the use case where the TA signaling cannot reach TV sets that receive broadcasts from a set-top box. This approach will enable those TVs to replace the output signal of a set-top box delivered through the HDMI with an ad spot received by the TV over its broadband connection. And the DVB CMTA group agreed time ago on a set of commercial requirements for those use case. So for this use case, now the commercial requirements are in the hands of the DVB technical module on TA chaired by Matt. That is translating then into a new DVB technical specification for this specific TA use case. And the other work is on DVB-TA with DVB-I, where DVB-I is the DVB technology enabling discovering of broadcast services delivered via broadband via over-the-top. So why then not extending TA to cover these kind of services? The DVB set up a joint CMTA-CMI group to check commercial interest between members in extending DVB-TA to cover these DVB-I services. The commercial analysis started in April this year, is a very recent work, And currently, the group is working on identifying and agree on relevant use cases. As the user way of DVB work, the group will then generate and consolidate a list of agreed commercial requirements for TA within DVB-TA, and we are expecting this by the end of this year. That's conclude my presentation on new stuff. I would say that just a conclusion that this work has raised very, very high interest in between the DVB members, and a lot of companies are supporting these TA works. If you are not a DVB member, please consider to join us. Thank you, and it's over to you, Matt. Thank you.
Yep, and that's great. Thank you. So as you can see that we haven't just stopped on our two-part specification. There are lots of more work to come, and the fact that there is a lot of work in this area just really underlines Angelo's point that this is significantly interesting for beyond DVB members. It always gets a lot of interest, and we're being kept very busy. So it's an important point. So yeah, so we move now to our question and answer. We've got 4 questions, although one of them has just been answered. But I'm not sure whether everyone can see that, but I'll start with Peter's question then, just as Martin has answered. Peter asks, is there a DVB-TA reference transport stream? And the answer is not yet, but we have a task force which is working on putting together peer-reviewed reference streams, which the ideal would be to include the DSMCC carousel event example, a pure SCUDI 35 example, and a TEMI example as well. I saw earlier someone ask a question about TEMI, which is very similar to Way's question, when the DVB-TA demo is possible to look at. We are basically, when we get to the point of having peer-reviewed transport streams containing the signaling, we will then move on to constructing an app. All of this is being somewhat made more difficult because we need access to labs. And with the lockdown, it's making generating test material more difficult. So it's a little bit difficult at the moment, but expect to see something in the next 12 months, we hope, I would say, in answer to the question of when a demo might be available. Lots of good questions coming out now. Chris Wass, hello Chris, asks, does the spec allow for the DAS app to make the decision whether or not to present an ad, even if it's not been fully preloaded? Well, that's slightly a receiver spec question, really, and we're dealing with a signaling spec and an ad server integration spec. So the answer is the author of the DAS app can do whatever they like, and the specifications in DVB don't say anything about it. If you want to know more about that from the context of HbbTV, I believe that later on in the year there will be a HbbTV webinar that will be spoken about specifically. The rules in the vertical market implementation may be proprietary to the operator. So it's, yeah, the answer is yes, but it's not so much a DVB question. Hilla asks 2 questions about seamlessness and landing zones. You ask that does that mean that presumably the discussion around reach and quality trade-off Does that not mean it can be all 100% seamless? The answer is maybe, and it depends, unhelpfully. I think where we are now with, as we roll out deployments, there may be receivers that could do better, and we expect that to get maximum reach, you might have to do a little bit more work to get it seamless. And the definition of seamless is somewhat subjective. To one broadcaster, they may allow a little bit of black between an advert, and others maybe not. The rules around how much black per market differs as well. So in some regions, there must be a large amount, a defined amount of black between adverts, and others, there must be no black between adverts. So it kind of depends upon which market you're operating within, and how much commercially the broadcaster is willing to sort of accommodate transition time differing. Slightly conditional answer there. So the max room for landing zone question, Hilla, is also a receiver specification question. So we didn't really deal with that. But if you wanted to know more, if the question was with HbbTV, I recommend you look out for the webinar that they're planning. And I quite rightly, actually, I've forgotten that we would said that we would show our faces at this point in time, and I've been hiding. So here we all are. Hello. See all our home backgrounds. I've been dealing with all these questions myself, and I'm trying to. Peter, how about you deal with Irv's question here? I think that given you are quite interested in SOME, why don't you try and tackle this question? Can you see it? And you're muted.
Yes, I can see. So SOME seems to be designed to allow broadcasters to bypass pay TV ops. How will that be reviewed by pay TV ops that certainly have their own ad-in strategy? So that's true. I mean, SOME solution has been considered and designed first of all to cater for legacy set-top box scenarios. So having the situation in mind that still there are a lot of hundreds, thousands, millions of set-top boxes out there which are not capable of doing dynamic ad substitution and which never will be capable of doing dynamic ad substitutions. But recognizing that TV sets are changed from time to time, and it may be the case that a new TV set is connected to an old set-top box, we may have a chance to even get these screens targeted. And yes, there may be the situation that a platform operator, as we call them, also provides for a solution, for a DAS solution. Then of course the best way would be that the broadcaster partners with the platform operator. And even then it may still be the case that you will have a mixed receiver population in a certain deployment scenario and still want to address TV sets connected to old set-top boxes, TV sets connected directly to the RF cable, and set-top boxes, advanced set-top boxes connected to RF cable. And the good news is that DVB allows to do this. So you will be able to address all of these devices by the signaling solution we provided. And you need to, as long as you take into consideration the capabilities of the receivers that you address. And this basically means, for example, you cannot, or you also always need to cater for the slow switching device, for example, as a rule of thumb, and things like that. And here we are still figuring out how to write this into guidelines in order to make sure that people who will use the DVB specifications for actual market relevant solutions will be aware of the relevant points and pieces of the tool case.
Okay, thank you, Peter. Hopefully that answered your question, Irv. So we've got a couple of questions about the commercial relationship, which we'll come to in a moment. But Vincent Gessien has asked, do we know of the French initiative to create specification for both distributor and publisher? Yes, we are aware. We've had some exchange of views with the broadcasters involved. And to be honest, we started independently and we'd gotten a long way by ourselves. So there wasn't a tremendous amount of interoperability or interplay between what we were working on at the time. So
perhaps I could comment on that from
yes, go for
perspective
it,
of the signaling specification development. One or two of the participants in the specification development were aware of the French initiative, but we understood it to be a private initiative and there was nothing published to us. We did try and encourage co-participation via the common membership, but that didn't occur. So personally, I didn't read it and I didn't take any ideas from it knowingly, because it wasn't really communicated to us. So I think there may still be an opportunity for coordinating in the future.
Yeah, thanks, Martin. Yeah, so we are aware, but it's yeah, there could be more participation in the future. Certainly, that we don't expect that this is the end for the work here. We're expecting this to be popular. So you know, we're open to correspondence from the consortia in France. So that leads us to two questions are about the commercial relationship point. One from Chris. Again, hello, Chris, and Martin. Hello, Martin. Slightly different questions. I think Chris had given that DVB-TA requires a commercial relationship isn't quite the right understanding. It's a technical specification. It says nothing about commercial relationships between broadcasters and manufacturers. So that's very important to point out now. There may be, it was a point that was a hot topic, as you know, as the broadcast industry becomes increasingly more digital, there are some who believe how revenue flows may need to change as well. But it's nothing to do with a technical specification. So I'm probably going to dodge the question. But I think, to Martin's point, do you think the commercial relationship between broadcaster and TV matcher is positive enough? Yeah, that's such a market-dependent question. Yeah, do we end up with bilateral relationships or consortia or JVs like we have in the UK and France? Who knows? It's all open. It's part of what makes this thing really, really interesting, because it's right at the heart of things as they change in the industry at the moment. So I would only advocate and encourage good relationships between broadcasters and manufacturers, as we already have always had in the market. So although I think, Chris, yours was coming from a slightly technical perspective, your question, I'll read it. Given that TV, well, we've dealt with that point, but it says, what is the mechanism that enables it? Okay. Well, there is not a specific specification that allows it. I would answer that. There is, if it comes up that a commercial relationship happens between a broadcaster or broadcasters and a manufacturer, then some mechanism may be dealt with, but it certainly depends upon there being reciprocal identification of each of them, and some means of having leverage in that conversation. But I have to reiterate, this is a technical specification and nothing to do with commercial negotiation.
But I would also, I would comment, of course, I mean, the question is somehow obvious, and it has really been a hot topic, just as Matt said from the very beginning. It's a statement of fact that the DVB-TA specification is not subject to any commercial relationships. It's somehow a little bit a different story if you talk about the receiver side of things, which is not DVB, but which is instead HbbTV. You will find a note in the specification which addresses this point. And in principle, in order to allow for different use cases, also non-commercial use cases, so meaning you want to be able to replace some content which is not an advert, and you may consider this to be, or that this doesn't require a commercial relationship or payments or whatever, then you will at the end probably also end up in a dialogue with manufacturers. And the instrument for implementing any kind of relationship with many manufacturers is authentication. So what you will be able to do is authentication. So a manufacturer will be able to authenticate against the broadcaster, and the broadcaster will be able to identify on which manufacturer's TV set the application is running on, and this provides the basis for every type of cooperation scenario.
Great, thanks, Peter. I will mark Chris's question as asked. We've got two more questions. One from Alfred. Hello. I think we've kind of had the question like this one already. He asks, are there any examples of the DVB-TA spec today? The answer is yes and no. I mean, there are no official DVB-TA implementations because the specs are only recently published, and but there are addressable TV products in market, and there are platform operators who have products that do addressable TV. So it's, as Angelo alluded to right at the very beginning, you know, this is a real business. It's happening, and the reason why we wanted to get together is to standardize, and that's obviously the benefit of what we're doing here, is we're trying to standardize the implementation together, so for overall benefit for everybody. So it's not, the answer is not a DVB implementation yet, but there are. And I don't know of any public announcements of people trying to do it, but you can assume that there are many broadcasters and manufacturers and technology operators involved in the specification, that there's lots of interest in implementing it. And Martin Harvey finally asked a question. It's purely a commercial question, which there's been a couple of these. So I think the DVB might be interested to know whether or not we have a follow-up commercial one, a commercial webinar that might deal with some of these questions in the same vein as next week's commercially focused multicast ABR webinar, because obviously it's quite a commercially focused subject.
Well, Matt, I can come in here. It's Owen O'Sullivan from the project office, and say that indeed it is our intention. DVB targeted advertising is one of the topics on which we hope to hold a webinar in this new model, where we look at the business case. Of course, it depends on the contributions from DVB members and other relevant companies, but we hopefully will in the autumn be able to address these kinds of questions in a further webinar.
Yeah. I mean, I guess if you want my opinion, it kind of depends upon broadcasters' strategies and the market they're operating in. So it's another "it depends" thing. And Avi thanks us for not inserting any adverts into the webinar today. Thank you for that.
So
well, it's a new revenue opportunity for the DVB project office to consider.
Indeed.
Yeah.
Well, I'm going to interrupt you all rudely there and say that if there were some signaling for some content replacement during that, it would have waited until now and maybe missed its opportunity, even its placement opportunity. We didn't quite stick with our timetable of finishing up at 3 o'clock, but still it was very good content, and we've had a very good attendance level with more than 120 people at peak on the webinar this afternoon. So with all of that said, I want to thank Matt and Martin and Angelo and Peter for joining us this afternoon. Matt, was there any final comments you wanted to make?
No, just to echo, it's great to see so much interest and so much penetrating questions. It just really gives us continued motivation to carry on the good work.
Great, hear, hear. So thank you to everybody, and I hope that some of you will be able to join us next Friday, Friday next week, for our multicast AVR webinar, and the slides will be on the website in about 30 seconds, and the video will be available hopefully later on this evening, but certainly by lunchtime tomorrow. Thank you very much, and we'll see you next time.
Thanks all. Bye.
Thank you.